So I thought I'd start off with a little bit of sunshine, because I don't think you get a lot of that around here, especially at this time of year. Yeah. So yeah, what I'm going to talk about today is what's next for React Native and Expo. We're kind of just going to go in this sort of format, some questions, work our way through there, and ultimately, hopefully, just get a better idea of like some of the current issues and what are things that are being done to solve these issues. But first, let's just talk about what React Native is even, because there's probably a decent number of people here who just have no idea. So React Native, you can make apps with it for iOS, Android, Windows, other things as well. Web is another possible target. The Twitter mobile app is made with React Native, or sorry, mobile website is made with React Native Web. And a big thing about it is you can share most of the code kind of like between web and native, if you start off from like this native point of view. And more importantly, though, you can share the knowledge between the platforms. So it even uses a re-implementation of Flexbox, the layout algorithm on the web. So regardless of whether you're on iOS or Android or on the web, you just have the same layout system. That said, if you've moved on to the CSS grid, you will not be helped very much, as that's not implemented yet in React Native. So as you can see, it's pretty similar. Like this is a comparable example with React DOM. So we just have hello world. Big difference here is just that there is a CSS file and an HTML file, and that's not the case in React Native. So what you get out of React Native is not quite the same as a website. The things that you see and touch are the screen, are the same things that you would get if you made the app with the native tools for iOS, Android, or Windows. So just for like a little metaphor, let's just say that on the web, you draw the interface with paintbrushes, and in mobile apps, you use pencils. I'm not saying anything about the fidelity here, just the materials. If you're using React Native, you would be similarly drawing it with pencils and not paintbrushes. So you have the same kind of materials ultimately. But in the end, it's, as we've seen, if you're able to share this kind of functionality, there are some primitives that are similar enough that it's actually not that different. It's just the underlying things and the primitives that are exposed that are different on the platform that ultimately make it powerful. So who is React Native? I mean, clearly it's Facebook. I think we all know that. So it's an open source project. It's mostly by Facebook. They kind of make the thing that makes the React code written in JavaScript kind of work on your phone and do kind of phone things, right? They do like the core part of it. But around that, there are a lot of other companies. There's Microsoft. They make a Windows version of React Native. They use it for Skype, recently as well for Office 365. There's Wix. They use it for their main mobile app, and I believe some other ones, PlayStation, Zynga for Words with Friends 2, Pinterest, Expo, as you know, which is where I work, but I'll talk some more about that later. So kind of infamously, maybe if you haven't even used React Native yet, and you go on Hacker News or follow any kind of pundits about tech, you might be noticing like one thing here that doesn't belong, right? So let's get that guy out of there. So kind of infamously, Airbnb has decided to sunset using React Native. So I think that's, I think they have pretty good reasons, and I'd recommend reading their blog posts. I think it's just kind of a coming of age experience for any technology that at some point it's not going to work for a company that tried to adopt it. So, yeah. So who am I? So as you've heard, I don't work at Facebook. I contribute to React Native. I work at this company called Expo. Again, I'll explain that a bit later. I've been working on React Native now since, I guess, just before it was open source to the public, and not because I had any like special access. Some early access was given to people at ReactConf, and I didn't even know ReactConf was happening at that time. And if I did, I don't think I would have been able to get a ticket. But somebody that I knew went there, and they got early access and gave me it on a USB with a zip file and whatever. And so I played around with it, and kind of from then on, I really got into it. And as soon as it was properly open sourced, I started contributing to it. And kind of interestingly, the following year, I ended up organizing ReactConf and hosting it also. So that worked out nicely. This is my dog, Lucy. And this is Sophie Alpert's dog. She works on the React team. She's a manager. So I mention this because I learned like a little bit of Danish in response to that tweet. Apparently, dog, 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 dog translates to however, however in Danish. Can someone actually verify if that's true? Is that correct? Yeah, I was seeing some, yeah, roughly. OK, so good job, Microsoft. Anyways, so back to the topic. Why do people do this, right? Why make this React Native thing? I think it's a pretty good question. Like, there's a lot of new stuff. There are a lot of different tools. Why do we need another one of these things? I think a big motivator is that people really like using React on the web. Like, they really like it. This State of JS survey shows how not only have a lot of people used it, but when they use it, they want to use it again. And there's the ratio there of people who want to use it again after they've used it to the people who don't want to use it again is pretty dramatic, especially if you compare it to the other technologies listed there. Vue, though, is also quite good in that metric. But yeah, sometimes your boss will come and say, hey, I don't need a website. Like, make me an app. Right? Or maybe you just say that to yourself. You're just like, you know what, I should make an app. So then when you go to build this app, you think, like, wait, this doesn't use any language that I know, or at least that I have used since I was at college. It doesn't use any of the same tools. And then now you go ahead and build one, and it turns out you have to learn all these other things just to make another one so that the person sitting next to you can use it on the other platform. So maybe you think, like, oh, I should quit my job and just go make websites. That's pretty reasonable, actually. But you probably have bills to pay, or maybe you have some other motivation for making an app. So ultimately, this problem needs to be solved. Yeah, so the people at Facebook, they're pretty clever. They said, like, hey, wait, let's just do the web thing on that one. And yeah, and then they did it, which is amazing, because people often just say, let's do this thing, and then don't do it. But they did it, and it's kind of nuts. And it mostly works, right? So let's look into kind of how it works and why it only sort of mostly works. So how does it do its thing? So I mentioned something roughly like this a few minutes ago. So how does that work? Well, JavaScript has this concept of host objects and built-in objects. So built-in objects are kind of like, they're the things in the ECMAScript spec. So you'll have like a string function, object, number, regex, however you say that. And then depending on the environment that you're in, there'll be different host objects. So in Node, maybe you have FS or HTTP. In the browser, document, XML, HTTP request. And these kind of just expose this native functionality that is specific to the environment. So on the web, you don't really have to use these. You can just use like HTML and CSS directly. But if you want to, you can call into document.createElement, get a reference to the element, set some attribute on it, append it somewhere. And so these are all synchronous functions that interact with some native functionality somewhere that's kind of behind the curtain. If you inspect the definition of these functions in DevTools, you'll see like native code. So you don't really know what goes on behind that. And it's kind of similar, I guess, to how that works in React Native. It's not the same, and we'll see how. But ultimately, there's some mechanism that is connecting these native-backed APIs to JavaScript. And so we're able to write things like this, and you'll still be able to get kind of this similar sort of result. The equivalent in React Native to document.createElement is this thing. It's not very ergonomic looking at it. Like, OK, I need to pick a unique ID before I create this view, and then pass in a class name, and then tell it what root ID, what's that even, and then pass in props. It's definitely not something that you would want to use. And in fact, I don't think I've ever actually just called this function. Usually, React Native just takes care of it for you. But this is the same sort of idea to document.createElement that you would have in the browser. And so what actually happens is, when you call UI Manager create view, it's not the same in that it doesn't return a handle to this new element that you've created. It just returns undefined. So you can't take this return value and set an attribute on it and append it somewhere. Once you do that, you have to call UI Manager update view and pass in properties if you want to change it. And really, when you call these, actually no work is really being done immediately. By the time we've called all of these functions, nothing has actually happened except for we've taken these functions and kind of transformed them into objects and put them in a queue sitting somewhere in our JavaScript code. So it's just this queue of commands. And what that tells us is that unlike the browser APIs where we create these nodes and interact with them immediately, rather than being synchronous like that, we are dealing with asynchronous behavior when rendering in React Native. So this is generally true for most of React Native. The interaction between the native runtime and the JavaScript engine is typically asynchronous. An easy way to see kind of the difference here is to look at local storage and async storage. Async storage is the equivalent in React Native. So who knew that was the logo for the web? Does anyone? I was like, I need a thing to represent web here. And apparently, Wikipedia tells me that's the logo for the web. Pretty great. So you call this local storage set item, returns synchronous, when that function is completed, when it is returned, you know that this is done. You get this value back, you have this variable that now stores the value of getItem. Whereas in the React Native equivalent, it's all asynchronous. So we can actually use await at the top level here. I think Miles will talk about some of that tomorrow. But just pretend that you could. And basically, this kind of shows you how you're going to be doing a lot of work in React Native. There's a lot of waiting for promises and callbacks and whatnot. So this mechanism that I mentioned of putting things in a queue and then kind of having this protocol for passing these messages, this is called the bridge in React Native. Other tools, like Phil mentioned, PhoneGap, they also have a concept of a bridge. And all it means is that you have these two runtimes, and you need to have some way of communicating between them. And the way that you communicate, for whatever reason, I'm sure there's a good technical one, is called a bridge. And it's no different here. Quite different, though, in the implementations of how they work. We won't go into too much detail on it, but essentially, the bridge, all of the communication is serialized, so you put things in this message queue, and then occasionally, I won't go into more detail, but let's just say occasionally, these messages are flushed from the other side, and they are deserialized and then executed, and the result of that is more messages that then get passed to the other side. And so it's probably kind of obvious at this point that you don't just accidentally build the bridge to be asynchronous. This was a design decision. It was intentional. But why would you do that? Because it doesn't seem quite as ergonomic as the document create element API or the local storage API. Well, a big concern when you write mobile apps, and especially if you use JavaScript for the mobile app, is performance. there are a lot of reasons for that. JavaScript is slower than compiled languages. It depends on cooperative multitasking for concurrency. GC pauses can lead to periods of unresponsiveness. And also, to make matters worse, the iOS JavaScript engine, JavaScript core, disables just-in-time compilation if you use it outside of WebKit. And so we don't have any JIT when using React Native on iOS. So there's some serious performance concerns there. And this topic is particularly concerning if the main thread ever has to block to wait for the JavaScript thread. So when the main thread is blocked, the app essentially just freezes. So you can kind of see that here. I simulated it by just rendering a bunch of maps. Maps are just expensive to render, and so I just threw a bunch of them there, and you can see that the UI thread or main thread frame rate drops to like 1 or 2 for a while. And so we really want to limit the frequency at which our app ends up in this kind of state where we have kind of janky scrolling and drop frame rates on the main thread. So this implies then that we can't really reliably make synchronous calls from native into JavaScript. We can't say, OK, the user is scrolling. Now, before we even finish this scroll event, I'm going to call into JavaScript and ask, hey, what should I do with this scroll event? Should I show some new content or whatever? The only option to not block the main thread in that case is to asynchronously just dispatch an action and wait to see what happens. So if we do that, the UI stays responsive, and you end up with something like this, where even though I've simulated here the JavaScript thread essentially blocking for a second, and you see the frame rate drop significantly, there's no difference in the scroll performance in the scroll view. All right, so it's not too important to go more in depth on how the bridge works, but this kind of key design decision has a lot of trickle-down effects to different parts of React Native. So we're going to have a look at kind of how this architecture stands up in the real world now. Yeah, it's actually not that bad most of the time. That said, while it's definitely not an accident that it was designed like this, it's quite possible that it was a mistake. We're going to see some of these things that kind of stem out from this that end up being quite problematic in some pretty common use cases, honestly, in React Native. So we're going to look at 3 of these cases. One of them is text inputs. Another one is gestures and animations. And then we'll look at lists. And then the last thing we'll look at, which is kind of aside from that, is embedding React Native into existing native applications. So text inputs. So when you're using a text input and you just mash a button on your keyboard, you expect to see that character in the text input right away, right? It's like that's the most important thing happening in your app at the time, as far as you're concerned, most of the time. So in other words, you expect it to be updated synchronously. Now, a very common use case with text inputs as well is that you'll want to somehow transform the text. So someone will enter some text, and you maybe say, OK, I want this all to be capitalized. Or they're entering a phone number. I want to add a dash here to format it according to how phone numbers are formatted. Or maybe you even just want to limit like the maximum number of characters in the text input. So unfortunately, when you try to handle these cases asynchronously, maybe a little bit hard to see. I'd recommend looking at one example at a time. But you see I'm kind of mashing the E key here, and occasionally you'll see like an E flicker, and it just shows up and then goes away. And on the other side, you can see as you input a character that you'll see the lowercase version of the character, and then it flashes away and you see the capitalized version of it. So when we handle this asynchronously, what happens is that you press the key, it shows up in the text input, some event is dispatched to JavaScript, some function runs that says, oh, hey, this thing isn't capitalized. I want to capitalize this now. And then sends that updated value back to the native side. And so you end up in some situations where that's slow for whatever reason. There could be many reasons, with potentially some flashing of the value. So you can work around this problem in some special cases, like max length. That's a very well-defined attribute, very commonly used property for text inputs. So we could just say max length is 3, and that's kind of equivalent to doing this, except it's no longer asynchronous. We don't have to call back into JavaScript for this to happen. However, we do have to define that somewhere in the native side of things. We have to tell the text input component on all of the platforms that we're working on, this is how you handle the max length attribute. Kind of verbose on Android, anyways. But moving pieces of logic like this to some native side so it can be handled synchronously, and configuring them through these declarative properties, it's useful in these general cases, but you can't really cover every possible case like this, right? We would have a capitalize everything thing or add hyphens, whatever. Like we would have, an unlimited number really of properties here to handle everybody's specific case. So that's not really a feasible solution. OK, let's look at gestures and animations. So out of the box with React Native, there are a couple of issues with gestures and animations. The first one is that React Native has its own gesture system that runs in parallel with the native gesture system in JavaScript. And that alone on the surface, I guess, isn't a problem, but there's also no way for the JavaScript gesture system to kind of define interactions between how it works with the native gesture system. They're both just running these parallel gesture systems in separate threads, completely unaware of what the other one is doing, with the exception of when one of them will occasionally call into the other and say, hey, cancel your thing, I have the thing now. So that's quite limiting. Second issue is that we need to call into JavaScript for every frame of the gesture. So if we say we've moved it to this position, we need to call back in and say, OK, what do we do with that value? We need to set this animated value and update the position or whatever you end up doing. And as we know, if you depend on the JavaScript thread being available, you're potentially running into some problems. So keeping these in mind, let's look at some code. So if we have a pan gesture that we want to activate when a touch has started on a particular view and has moved, say, 20 points to the right. So we touch and move over like this. That would say, OK, this gesture belongs to this thing now. Whereas if you touch and move to the left or up, that wouldn't recognize. So probably the most intuitive way to write that would just be something like this. And React Native gives you a pretty similar kind of API for that. It's called pan responder. We can then extend that so that after it's recognized, once we move, we update some x value and y value, and then just update the actual position on a view. So kind of gives you this. Looks OK. Looks fairly ergonomic, nothing kind of crazy. You don't really have to learn that much to use it. And when it works, it's fine. Unfortunately, it only works sometimes, and not particularly well. So one of these cases I mentioned earlier is you can see in the horizontal scroll view on the left that I'm trying to drag that view, but it's conflicting with the scroll view gesture. And we have no way of telling the scroll view, like, hey, just wait a minute. We're in this state with this gesture where it's possible that this thing will still recognize, and we want this gesture to be active for this view. We just can't do that. There's no way to express that with this gesture system. And the other issue is performance. So you can see that if we reduce the frame rate artificially on the JavaScript thread, you can see that it just kind of jumps around, and can't really depend on every frame having the JavaScript thread free. So we can solve the first problem by moving to a gesture system that's implemented entirely natively on top of the native gesture system. And we can just add this pan gesture handler. And it's very similar to how we add max length. We can set active offset x to a certain value. And now we've essentially just done the same thing as we did with max length. We've said, OK, take this code where I would previously write if this, then true, else this thing. And now just throw that on this property, and you can adjust the condition. And that's about it. But this handles our issue quite well, right? We are no longer using this native, or rather this parallel gesture system. We're using the same gesture system that exists on the platform. And that works out pretty good. Now for performance, we run into kind of similar performance problems with animations as you would with gestures. Because similarly with animations, if you just fire an animation and every frame you expect it to call back and do something like calculate the opacity and then update the opacity for the view. And if you ever miss a frame, you're going to have a janky animation. You can express that same sort of pseudocode that I had there using this API built into React Native called animated. And the key thing here is that there's no function that we're calling on every frame. We're kind of trusting the internals of this API to do that for us. Instead, it's, with the exception of there being a call to start, everything is declarative. And so what we can actually do here is that we can serialize this configuration and take that on the native side and run it there so that it's running on the main thread rather than in JavaScript. And so we can have animations that aren't bound to the JavaScript thread. And this is just generally true. You can't serialize arbitrary functions. You need to express whatever it is you need to do with some kind of configuration object or something like that, and then have some recipient on the other side that understands it and executes it. Now, of course, if we go back to the gesture, you can see that we have this onGesture event, which is a function again. That's another thing that we can't serialize. So we would still have to call back into JavaScript for that if it weren't for this other utility called animated event. And what this does is it allows you to map some inputs to an event to some other variables. So here we are basically saying this translation x, when this updates, update this.x with the value of that thing. So it's just a way of declaratively writing a type of function that takes some arguments and then updates some values with the values from those arguments. And we're able to similarly run that on the main thread, and then we have this kind of fun. So OK, so it's getting a bit better. Definitely adding a bit of complexity compared to the original example, but let's keep going and see what else we can do. So we've handled this basic case now of just taking an argument and mapping it to something and updating these values. But a very common case with any gesture is when you release it, you need to do something. Or even just potentially during the gesture that you're doing, there could be you enter a certain area, something happens, whatever. There could just be different conditions and logic around that. But we'll look at the very common case of saying you release the gesture and it springs back. So unfortunately, this means that we need to call back into JavaScript again, because we don't have any way to say, when you're done, do this. Like, we don't have a declarative mechanism for that, at least from what we've spoken about so far. But this is what you can do. You can use this alternative implementation for animated called reanimated. And it lets you express conditionals, do math, perform effects. You can start and stop things. And as far as I can tell, you can pretty much handle most things or anything that I've seen with the gesture with this API. So if we look at it now. I have very low frame rate there. It doesn't really matter because it doesn't even care about the JavaScript thread here. So this is a pretty good workaround, but it does come at a cost, right? It's great to be able to do this, but we've kind of like taken some steps back in terms of ergonomics. It's much more difficult to write that than it would be to write the equivalent JavaScript function, right? You have all these different words there, like you're essentially writing like Lisp, like a Lisp mini program inside of your program that handles your animations with your gesture. You can, of course, build abstractions on top of it, but it's definitely worth considering the ergonomics trade-off there. OK, the third one is lists. So designers at Apple that worked on UIKit, or maybe engineers, made the choice that basically they're going to freeze your app when you scroll and a new cell is going to be shown on the screen until that cell is ready, or until you say that it's ready. So this function basically is called when a new cell is needed. The implementation of it, you provide the implementation, and it takes some cell and mutates it, and then returns the cell that should be shown on the screen. And your app is essentially frozen until you return that cell. You can't return a promise or a callback or whatever. You have to return the thing that will be shown there. So as we've identified, there's no way to, at least reliably, and also technically no way at all really, to call synchronously into JavaScript and get some component back really in this kind of format. So the architecture is just kind of incompatible with this API. So when lists don't synchronously load new content, you end up with some weird stuff like this, because you have to do a bunch of optimizations around lists. And so the choice made here is, rather than recycling the views, it's kind of like a windowing approach, like React Virtualized, and I think a bunch of the other web libraries for doing long lists. And so this is very exaggerated in terms of what happens, but it's the same sort of idea. If you scroll to some content and you don't have enough time to render that content yet, it's just going to be blank. So that's definitely not a great experience with lists. OK, and the kind of last issue I wanted to discuss on this is embedding in existing applications. I think a key part of the success of React, not React Native, but React has been its ability to be incrementally adopted in other larger systems. So maybe you have Backbone as your app, or had that, and you maybe piece by piece convert it to using React. And this has been kind of possible with React Native. Facebook does this in a lot of their apps, like their main app and in Instagram. But it's definitely not without its challenges. One of the issues is that it's quite expensive to initialize a React Native view. So if you just have a component that you just drop in with other native views, you have to be really thoughtful about how you do that, because there's an initialization cost that comes along with it. And there's all these kind of this is just one of the things that happens is when you initialize a root view, it's called, you have to basically generate a list of all of the callable APIs on these native modules that you can call across the bridge. Those are generated at runtime through reflection and then injected into JavaScript, and then it generates these like proxies. So that's just one of the things that is quite expensive to do, that leads to fairly slow startup. Another thing is that this asynchronous architecture doesn't allow for you to synchronously render a React component in kind of like mixed in with the rest of the app. And this is just kind of the expected behavior of native views. You want to be able to synchronously render them. So if you have a list, and then one of the items in the list is a React component, what you end up with is kind of subpar experience. You can work around it in various ways, but if you need to have the actual view itself do its own layout, and you can't just know that it's some fixed height, you end up in this situation where you drop the view in, and then sometime later it finishes rendering, and then there's a jump in the layout because finally it has some layout. OK, so clearly there's some room for improvement in React Native. So what is happening now to kind of address these issues? I think that maybe the greatest strength of React Native is that it is built on top of React. If that wasn't true before, I think it will be true soon, thanks to React Fiber. So what we're looking at here is, if you don't use React, maybe you're not familiar with this example, but it's demonstrating the performance. Let's go back. There we go. Kind of the performance characteristics of using this new re-implementation of React called Fiber. And you can see when we enable the optimizations, it's a lot smoother and a lot more responsive to hovering in certain places and whatnot. And so there are some reasons for this that I won't go into here, but essentially it comes down to this feature called time slicing. So what it does is React doesn't block the JavaScript thread while rendering. It sounds a bit weird, because obviously it has to do work, right? So like, how does it do that? So the previous implementation was known as the stack reconciler, a stack implementation. And this one, yeah, is known as Fiber. And Fiber has a very specific goal. The goal is to improve the perceived performance of React apps by making work interruptible using time slicing and prioritization. So it adds this new mode for interruptible rendering, which is called concurrent mode. So if we look at what a call stack would look like for the synchronous mode, which is what everyone is using today unless you opt into this experimental scheduling package, what you end up with is basically this kind of monolithic re-render of your app. So if you're re-rendering your app from the root, you could see that here, it's actually hard to read, but it says 550 milliseconds. So this entire thing, like we're just re-rendering everything in the app, and it all happens in one chunk. And using this existing approach, there's no way to break this up. So your JavaScript thread is going to be blocked by React for the next 500 milliseconds when you re-render. Using concurrent rendering or concurrent mode with Fiber, it prevents this kind of thing from happening by slicing the rendering into different chunks. And it allows you to kind of pause and resume work. And as higher priority work comes in, you can put some lower priority work aside, do this new work, and then rebase the previous lower priority work on top of the higher priority work that completed. And this essentially is the key thing to what makes that example look a lot smoother, because the kind of jank that you see when occasionally, I think it's every second, it freezes a little bit, it's because it's re-rendering from the root and updating every single triangle to change the number. Whereas using Fiber, you can specify that as a lower priority update. And so it'll render and update different parts of the tree in its internal representation. And then once that's completely done, it will flush it and update the entire view. So this is really important for kind of helping with this significant limitation of React Native, where we just can't reliably synchronously call into the JavaScript thread, because at any time previously we could have been blocking on this massive reconciliation. But if we're able to break up our work so that the rendering is just done in smaller chunks and kind of like do some work, come back up for air, yield to other tasks, go back down, do some work again, then we're able to potentially change the way that React Native works, such that we can make synchronous calls into JavaScript, and we potentially don't have to do these kind of workarounds in every case in order to move a lot of the logic into declarative APIs. So Fabric is this new architecture for React Native, builds upon React Fiber, and provides opt-in synchronous execution where it benefits performance, UI responsiveness, and simplifying inherently synchronous interop APIs. So I think this pretty much covers most of the problems that I mentioned before. Of course, how this actually plays out in practice is hard to say. It's currently not completely available for use. You can try to build it yourself in the open source repo, but you might have a hard time. Another thing that Fabric supports is synchronous initial rendering. So this would resolve the other issue of when we're embedding a view and we want to just have this React component in one place. We don't have to have some blank view and then suddenly some layout jumpiness. And it's also worth mentioning that kind of a non-goal for Fabric is to come out and solve all of these problems for you. Instead, it's meant to be this re-architecture that enables the community and I guess other people at Facebook as well at some point in later projects to solve these problems on top of this and kind of just rethink how things are done so that it's possible to actually have an ergonomic solution to a lot of these problems. In addition to React Fiber and Fabric, there is this project called JSI, which just means JavaScript Interface. And essentially, it's meant to be a replacement for the bridge. And what this does is kind of, it's meant to make the interop between the native and JavaScript runtimes kind of work more like how it works in the browser. So something like this would be a feasible kind of path in the future for how you can interact with the native runtime. Another active project is called Turbo Modules. I don't know who comes up with these names, but so Turbo Modules, the basic goal is to speed up initialization. We mentioned this is another issue with React Native, the expensive cost of rendering a React view just wherever inside of your app. So it speeds up initialization of the app by essentially removing this runtime module config generation and instead turning that into a build step that generates these C++ wrappers that are then used by this JSI interface. So there's definitely not enough time to discuss all of those things in detail, but if you look at the discussions and proposals repository for React Native, there's a bunch of information there for each of these things. All right, so what else do I have? Well, as we keep moving forward with React Native, of course, we keep getting new updates to React. So things like hooks, support for that will be landed quite soon. You can already use it now if you want by just updating the React version in React Native manually. Suspense, so you can, don't know if you know about that, but it's definitely check it out if you haven't heard about it yet. And just whatever Dan comes up with next, who knows what it'll be. I'm a proud member of the Church of Dan, so. There's another project called the Slimmining. So basically, currently the core of React Native is this really big monolithic kind of thing that contains all sorts of APIs from push notifications to like make your phone vibrate or like share sheet and a whole variety of things that kind of don't really belong in this core of React Native. And honestly, they would just be better served living in their own repository and having this focused sort of core to React Native that is essentially just the layer that does the main rendering work and provides this platform to build on top of. Of course, there's a trade-off here, and the trade-off is that you will now probably have more dependencies in your project. It's definitely nice sometimes to have this like trusted layer of things that you know, I'm on this version, so I have this version of all these other things. Okay. time-wise, pretty tight, but I will rush through this part. So what's Expo? I mentioned it before. Expo is a company that builds tools and services around the core of React Native, and it kind of tries to provide this cohesive end-to-end experience of building apps with React Native. We have a pretty humble goal. We basically just want to be the best way to build most apps. And kind of as the responsibility of React Native contracts, so as this limiting project occurs and more things are pulled out of the core, projects, I think, like Expo are going to be important to provide a smooth kind of getting started experience at least, and potentially more beyond that. So you can kind of think of Expo in some ways as like, so Expo is to React Native kind of like what Ruby on Rails is to Ruby, sort of, kind of. It's not the great comparison, but it gives you a rough mental model. So quick look at some of the things it does. So you can use the Expo CLI as kind of this main entry point. It's basically like create React app for React Native. It's in the docs because by using this, essentially you can get started in a few minutes compared to if you don't have any build tools on your machine like Xcode or Android Studio, maybe a few hours. So definitely helps a lot with the first-time experience. Then there's a client app on the App Store, which we'll open here in a sec. You can also install it in the simulator. And what that does is it makes it possible for you to essentially run these projects that you create with Expo CLI. Kind of contains this shared native runtime that allows you to just load some JavaScript and run stuff. So I just opened an app inside of it that I published to our servers, so you can also update things and sort of use it as like a browser in some ways, but not quite, because browsers are not allowed on the App Store unless they use WebKit. So another big part of it that I mentioned is kind of the extensive API wrapper functionality. So there's this library built into it called Expo Kit, which you can use on its own, but it also is just built into the client. So it gives you a bunch of these APIs kind of out of the box, so you don't have to install anything or set anything up. You just import them, and you get a map, and you get GL view and things like that. And it's just there for you, and just a lot easier kind of experience out of the box. And then there's also this tool called Snack, which is like CodeSandbox, but for React Native stuff. Here, I'm just using the simulator to open this thing, but there's also like a preview in the browser you can use that isn't quite as good because it streams kind of a simulator off in a VM somewhere, but it's definitely, in a pinch, quite useful. And yeah, you can do all sorts of things with this. You can install packages from NPM, upload assets, and do whatever. And then save it and share it with people. So this is kind of a piece that's really important, I think, in the React Native community, because it's a great way to share reproducible examples or bugs or that kind of thing. And also just useful for testing out ideas. I don't think I have to convince web people that this kind of thing is really useful. Then there's also this build service. So you run a build, just uploads your app somewhere, and then on some server, it will download the app, do a build, give you the IPA or APK, and then you can run another command to upload it to TestFlight or to Google Play. So the trade-off here, of course, is that if you're using this like workflow, you can't just introduce your own native code. You don't have access to like the native projects. You can't just add a file here and there and a different module and whatnot. You kind of just have to go with what's built into it. Similar to how in a web browser you can't just decide, well, unless you use like WebAssembly, but you can't just add arbitrary extensions to the browser. Yeah, that's what that looks like. So we've seen a lot of successful users at smaller companies and kind of a handful of bigger success stories as well. For example, Spin, they were recently acquired by Ford for $100 million, which is a good amount of money. They got started with Expo And they eventually had to move away, though, because they needed more flexibility. I mentioned that limitation. If you use this builder, then you can't just introduce your own native code. And the way that you move away is you eject. So it's like create React app. If you want to have access to those files, you eject, and it will just create a project that has the ExpoKit SDK just linked to it right away. Nice. So a common criticism against Expo is that the toolchain is, people say, only good for like small apps or prototypes. And I think that's a pretty reasonable criticism in a lot of ways, because just like the eject workflow was like the last thing that I showed you about Expo, it's also kind of, that's where it's sat on our priorities. It's not as smooth as it could be. And yeah, we really need to work on that. And we've kind of learned that no matter how many APIs we provide, this is just an essential thing that you need to do. You need to be able to add some native code. So in addition to making the eject workflow first class, we have spun up several other projects that kind of try to address some of the biggest pain points. So things like adding background APIs, TypeScript. We just haven't found people have enjoyed using Flow, honestly. It can be quite problematic, at least in the React Native ecosystem. So moving everything over to TypeScript, and also investigating adding the web as a target. OK. And this is my last one here. So kind of just looking further out, we're curious in exploring like what would React Native look like if it were even more web-like. Like what if loading scripts was the same as on the web? And what if it used Webpack so you could take advantage of all the code splitting kind of things? And as soon as something like React Lazy came out, and integrate that right into Webpack and load whatever, just use it in the same way you would as the web. And what if all of the like core JavaScript from React Native and ExpoKit, what if that didn't have to be included in every bundle, but it was just part of the runtime? And potentially, we could do things like VM snapshotting to load it more quickly, and then just kind of your app piece by piece would be loaded as needed. And so these are kind of areas that we want to keep exploring. And if you have any ideas around this, any kind of crazy ideas, let me know. And I'd love to discuss it. Yeah, pretty much. So thanks to the organizers for having me here. This last chart here is just showing, similar to the React one, how satisfied people tend to be with React Native. So although I've mentioned a lot of these problems, generally speaking, when people use it, they want to use it again. So that's quite promising. Yeah. Now I need to let the next person speak about Flutter, and I'm actually looking forward to that. So I will take a seat. Sorry for taking so long. Bye.